Hello, this is the second one of the series of videos on vector space classification. In this one, I will introduce Riccio classification. First, we need to know what is decision boundaries. As our previous Skittles example showed three classes, China, UK, and Kenya, in a two-dimensional space. Documents are shown as Skittles. The boundary in this example, which we call decision boundaries, are chosen to the three classes. To classify a new document represented as a blue skittle in the picture, we determine the region it occurs in and assign it the class of that region, UK in this case. Our task in vector space classification is to devise algorithms that compute good boundary. So what is good means? Good means high classification accuracy on data unseen during training. Perhaps the best known way of computing good class boundaries is Riccio classification, which use centroids to define the boundaries. Here is the equation. The centroid of a class C is computed as the vector average of center of mass of its members, where D subscript C is the set of documents in D whose class is C. D is a member of that set of documents, and the normalized vector of that document is represented by vector VD. Go back to our example. Now we can use the central equation to generate three purple sums as the centroid for each group. The boundary between two classes in Riccio classification is the set of the points with equal distance from the two centroids. To make it more clear, we will remove Skittles just for a few seconds. The boundary between UK and Kenya is the green line. A, B, C are points in the boundary lines. From the centroid of UK to point A, the distance is A1, while from the centroid of Kenya to point A, the distance is A2. The absolute value of A1 and A2 is the same. The distance of both centroids to point B and C are the same as what happens to point A, which means the absolute value of B1 and B2 is equal, and the absolute value of C1 and C2 is also equal. The set of points like A, B, C is always a line. Let's look at the Riccio's algorithm. First, we need to train the samples. For each class Cj in a set of C of all the class, assign to D all the documents in the set of training documents that in the class Cj. Next step is to calculate the centroids for that class of documents by computing the vector average using the normalized vector for all documents in class J. It will return the set of centroids. Then we can apply Riccio, and we need the set of the centroids and the document. It returns the nearest centroid to the given document. Finally, we are going to use the Riccio algorithm to assign the blue one to the perfect group. First, we have central for each group, and we need to compute the distance from the blue skittle to each centroid. It is obvious that the pink line is the shortest one among these three lines. Therefore, the blue one belongs to the topic of UK. Thank you for watching this video. Please check the next video focusing on K nearest neighborhood.